A paper bag like this one takes 2 to 6 weeks to decompose in a landfill, whereas a plastic bag like this one that I'm holding in my hand takes about 1,000 years or 10 centuries. Which would you prefer for the longevity of this planet? It's your own choice. So, having a positive environmental impact can seem a little bit daunting until you realize that even small changes in behavior can offer a great benefit. One of the most common suggestions is to eliminate or reduce single-use plastic bags from your shopping errands. That's when you go down to the grocery store, bag up the groceries, you use them one time and that's it. That's because the bags decompose slowly, causing them to linger in landfills. But how long does that plastic bag stick around? Like I mentioned, about 1,000 years, and according to the Center for Biological Diversity, for a bag to decompose, but that's a bit of a misnomer because most microorganisms can't eat plastic. It winds up photodegrading from ultraviolet radiation in a landfill. And even when bags disintegrate, they leave behind microplastics that can continue to have an adverse effect on the environment as well. Most plastic is manufactured from petroleum, the end product of a few million years of natural decay of once living organisms. Petroleum's main components come from lipids that were first assembled long ago in those organism cells. So the question is, if petroleum-derived plastic comes from biomaterial, why doesn't it biodegrade? A crucial manufacturing step turns petroleum into a material that's unrecognized by the organisms that normally break organic matter down. Most plastic are derived from propylene, a simple chemical component of petroleum. When heated up in the presence of a catalyst, individual chemical units, monomers of propylene, link together by forming extremely strong carbon bonds with each other. This results in polymers, long chains of monomers, which are called polypropylene. For example, they can very quickly break down polysaccharides to get sugar. They can chew up wood, but they see a polypropylene with all its carbon-to-carbon bonds, and they don't normally break something like that down, so there aren't metabolic pathways to do it. But if you have to do or make polypropylene subunits turn into polypropylene is to heat them up. Why doesn't nature even build polypropylene molecules? It's because the carbon-to-carbon bonds in polypropylene require too much energy to make. So nature chooses other alternatives for holding together large molecules. It's easier for organisms to synthesize peptide bonds than carbon-to-carbon bonds. Peptide bonds, which link carbon and nitrogen, are found in proteins and many other organic molecules. Environmentalists might wonder why plastic manufacturers don't use peptide bonds to build polymers rather than carbon-to-carbon bonds, so that they'll biodegrade rather than lasting forever in a landfill. Unfortunately, while peptide bonds would produce plastic that's biodegradable, they would also have an extremely short shelf life. So today, it's true that manufacturing paper bags requires more energy than plastic bags. However, consider this: the paper bags are made from a renewable resource, which are trees. These trees absorb carbon dioxide during their growth, helping mitigate climate change. In contrast, plastic bags are derived from oil refining waste products, contributing to greenhouse gas emissions, which heat the earth. While paper bags consume more energy during production, their long-term impact of carbon sequestration makes them a much better choice. Paper bags are easily recyclable. They break down naturally and can be repurposed into new paper products. Recycling paper bags reduces the strain on landfills and conserves resources. Plastic bags, especially those single-use ones, pose recycling challenges. They often end up as litter or take centuries to decompose. So, in the end, paper bags win in the recycling department. And when discarded, paper bags decompose relatively quickly. They don't linger in our environment, threatening wildlife, and unfortunately persist for ages like plastic bags do. They break down into microplastics, infiltrating ecosystems and harming marine life greatly. So paper bags biodegrade faster, leaving a smaller ecological footprint, better for the earth. And producing paper bags requires more water than plastic bags, although that water-intensive tree farming can be managed sustainably. Plastic bags consume less water during production, but they do wreak havoc on aquatic environments when discarded. So we need to have a balanced approach here. Water-wise practices can make paper bag production more sustainable. Now, I think we all admittedly know that paper bags are a little bit less durable than plastic bags can be. They tear a little easier, especially when they're wet. And plastic bags, the sturdier kind, they outlast paper bags, but remember, we're talking about going to the grocery store, getting a single-use bag, and trying to dispose of it. So, while durability does favor plastic, let's consider the overall life cycle impact that it has. I think if we look back, we want to make sure that to be invincible, they're resilient. Choosing paper over plastic is a choice that we all are going to have to make. But paper will contribute to a cleaner air, healthier forests, and a planet that thrives. So, it's your choice, but next time you're at the grocery store, the paper is going to be much better for the earth than the plastic will be.